Good fuel, good fuel.
GM. Hello everybody, and welcome to another live stream. We're here with Garuda from Simply Staking. What's up, my man?
I'm really good, man. How are you?
I'm doing good. I'm doing good. I'm pumped up from that intro music.
I
That went
know, I
way better
know.
than I was
I
expecting.
was, I was dancing a bit, actually.
Very cool, very cool. Well, I'm excited to be chatting with you today. We got a lot of stuff to talk about and kind of doing our deep dive into Fuel's decentralized sequencer. Yeah, to jump in, I mean, I guess, do you want to do a quick intro on yourself, on Simply Staking, and how you guys have been involved in this project?
Yeah, absolutely. Be my pleasure. My name is Garuda. I work for a company called Simply Staking. I'm not actually part of Fuel Labs, although I feel like family because we work so closely. Simply
Definitely the
Staking,
Fuel family.
yeah, thanks. Simply Staking is a infrastructure company. We only do Web3 essentially, based out of Malta, but we've got colleagues all over the world. Essentially, we're like any other Web3 firm out there. The business is primarily split along two lines. It's the staking business where we have our own data centers situated in Europe, South Europe and Northern Europe, as well as North America. And I think there's a push to deploy more data centers in other parts of the world. So we run our own data centers and infrastructure. So we're not dependent on other, AWS or Hetzner. So we're pretty much anti-fragile and true to the Web3 ethos in that sense. And then we've got the other side of the business, which is the engineering side of the firm, where I sit in. And it's on this side of the business where we're working with you guys on the decentralized sequencer. We've got a number of other customers like Chainlink, and we've built Oracle networks, managed some Oracle networks as well for other foundations, and a whole bunch of dApps.
Awesome. You guys do a little bit of everything across the space, so it's great to be working with you guys. To jump into our deep dive, I guess before we dive too deep, um, I guess a question some people might have is like, what is a sequencer in general? What is a decentralized sequencer? What role does like a sequencer play in layer twos kind of across the whole like Ethereum ecosystem?
Yeah, that's a good question. And simply put, right, the roll-ups produce transactions, but these are unordered transactions, which ultimately need to be settled on an L1. And Ethereum-centric roll-ups like Fuel, like Arbitrum and Optimism, they all settle to Ethereum. So there's essentially a pipe that links the roll-up to the mother L1, and that's a sequencer, right? And traditionally, it's a centralized sequencer has been used. There are quite a few flaws in utilizing that, and the end game is to, of course, decentralize it. We'll obviously get into the weeds as to why a centralized sequencer is a poor choice. But yeah, that's a sequencer in a nutshell.
Gotcha. So basically, every rollup has a sequencer that's like processing these blocks, and my understanding is for the most part, most of all the existing rollups have centralized sequencers, right? Like Arbitrum, Optimism, Base, they're all using kind of a single server essentially, like to sequence these chains, right?
Yeah, I mean, it's a really interesting situation we find ourselves in within Web3, right? Um, so there was a very interesting report and analysis done by the Aztec network crew, and they did some analysis, on-chain analysis, and they worked out that sequencer cash flows exceed $150 million cumulatively, and I found that absolutely gigantic, to put it lightly. Base, for example, was producing 60 million in cash flows alone.
Hmm.
Um, Arbitrum was like 20 million or something like that. I didn't do the analysis just to
Hmm.
stress that point, but I found that absolutely incredible. So the reason why I bring that up, right, is there's clearly an incentive mechanism that's misaligned with Web3, in that a centralized sequencer is producing, a significant amount of cash flow. But if you're the entity that's already deployed that centralized sequencer, and you're producing that cash flow, are you inclined to go and build a decentralized sequencer, especially given the technical and operational challenges. I think it would not be a sound move for any project unless they're massively dogmatic about doing so. So I think and you kind of see that manifesting in a different way, because you've got projects like Espresso and you've got projects like Astria and Rome, who are building decentralized shared sequences. And we can go into the nuances between why it's called a decentralized shared sequencer later. But these are the guys that are building this infrastructure and decentralizing the sequences, not necessarily Arbitrum or Optimism directly. The exception to that rule is, of course, Fuel, as well as, I believe, Metis as well. But I'm not too sure exactly what state the Metis
Mm.
decentralized is at right now.
What about, you mentioned Aztec? I think, does Aztec have, are they
I
pursuing
believe
a
Aztec
decentralized
are
sequencer?
building their decentralized
Mm.
sequencer, but I wouldn't want to comment because I'm not as learned on their
No,
state as
no
I should.
worries, no worries. Well, but anyway, so you were kind of alluding to, these companies are making tons of revenue and through their sequencers. And in fact, I think I even saw some tweets about, I think Coinbase had their like earnings report out recently. People were commenting on like the retail exchange is actually becoming like a smaller piece of their overall revenue. And I think the sequencer is a big line item of their revenue. You alluded to these projects are probably not very incentivized to decentralize their sequencer. What is the problem with them having these centralized sequencers, right? Because rollups do inherit the security of the layer one, right? So what is the problem with this current situation?
Yeah, I think let's start off with the macro view. Like the promise of Web3 is, censorship resistant, unpermissioned infrastructure. We're living in a time whereby being blocked and cancelled is a real issue for right or wrong reasons. Okay, I'm not going to comment on this on specifics, but most people in Web3 want access to this infrastructure in an unpermissioned way, and I think we're doing a disservice generally if we are relying on centralized infrastructure for long durations, well past what was intended, the timelines intended. So you can launch an optimistic rollup, and actually I'd like to give credit to the Fuel team, Fuel V1 being the first optimistic rollup, making history. But if you're going to rely on the centralized sequencer, at least rely on it for a short term and make significant gains on developing this further. So the way I see it, the issue is as block space becomes cheaper, economics teaches us that actually, as a resource gets commodified, you're going to have an increase in the usage of such block space. Volumes increase tremendously because it's cheaper, and as a result, the application builders are also maturing, coming up with crazy designs that are more resource intensive, and again, Fuel is paving the way on providing that capability. And so, as people get more dependent on these complex applications, regulatory scrutiny is a significant issue. And most of DeFi applications, they purport that everything is decentralized, and therefore, because it's decentralized, we don't need a license. Essentially, that's the narrative and that's the argument made. But if you've got a centralized sequencer being run by an entity, then actually it's that entity that will probably get penalized by the local authority. So in short, regulatory risk is a big issue. But as I mentioned earlier, censorship resistance is a fundamental attribute of Web3 technologies, as well as liveness. If you've got a single entity running the show, for whatever reason, they may decide to make other transactions or services more advantageous than yours, right? Or provide advantages for other services other than yours. Or if they get knocked out for some reason, there's going to be a liveness issue. So those are the three main reasons why anyone would want to, decentralize this pipe into the L1.
So basically saying like if you have this centralized entity, you're kind of subject to the wills of that entity and basically the jurisdiction that they fit in, right? So I guess
Yeah,
like example would be like I used Tornado Cash for a while, not to do anything illegal, but just because I wanted some privacy. And actually, I still have money in there. I know there's been some court cases, but I think it's still illegal for me to pull my money out of Tornado Cash. It sounds like you're kind of saying that if there's a centralized sequencer, if there's Tornado Cash on base, and base is obviously a U.S. company, I assume their infrastructure is in the United States, that if the government decides that, David's not allowed to have privacy, they can kind of they can freeze that contract. They can censor my transactions effectively, right?
Potentially, yeah, the potential is
Mm,
there. And I think, um, the arc of reality is you go into a sector, as they say, being naive and wanting to do good, and then later on, things happen, and motivations change. So
sure.
I think it's important to set the standards as soon as possible to
Mhm.
be more
Yeah.
decentralized. I think, just overall, um, you can't be a decentralized stack if you've got, a decentralized roll up, with a pipe into an L1 that's centralized,
Mhm.
and a decentralized L1. You're effectively
Mhm.
still centralized because of that issue in the middle. So, in order to be fully decentralized, we need to decentralize this
Yeah.
critical component.
Okay. So how does the decentralized sequencer effectively solve this? What does a decentralized sequencer even look like? And I don't know if maybe this is where you want to touch on, like you mentioned there's decentralized sequencers, there's shared sequencers. Like, what's the difference there, and how do
Yeah.
those address the problems that we've discussed, or other problems?
Yeah, this is a great question. So, decentralized sequencers essentially refer to multiple operators all coming to a consensus on a state, and pushing that state through to the next block, right? And that becomes the reality. A shared sequencer is essentially a bit of infrastructure that interfaces with multiple rollups. Now, if you combine the two together, you have a decentralized shared sequencer, and that basically means you've got a sequencer that interfaces with multiple rollups, ingesting data from those rollups, producing a block of some kind, and that block has been produced by a consortium of operators powering that network. That's what a decentralized shared sequencer is.
Gotcha. So the decentralized sequencer means that I guess it means that it's run by multiple nodes, right? It's permissionless to join to operate a node, so you can't really, like, no one actor controls the network, right?
Yeah, that's correct. That's
Yeah,
correct.
yeah, and
Yeah.
yeah, and a shared sequencer would be a sequencer that applies to multiple rollups. Now, the fuel sequencer only is sequencing the fuel ignition rollup now. Yes.
Yeah, that's correct. But it has the potential to ingest blob data from other fuel rollup. So if there was someone who wanted to instantiate, a roll up using the fuel VM and call it something else, it has the possibility of interfacing with that, with the same fuel sequencer.
Okay, so basically, the fuel sequencer, it is a decentralized sequencer today,
Mhm.
and it is not a shared sequencer, even though it is capable of being a shared sequencer. It's just not a shared sequencer by nature of it's not sharing, uh, anything with anyone, right?
Yeah, exactly, exactly.
It's kind of
So we need a second or a third party to start posting blob data, and that's the
yeah,
data type that the sequencer ingests. We'll probably go into more detail later on in the
yeah,
conversation. But yeah,
makes sense, makes sense. So this all makes sense. So Fuel has, like, taken the step to build out the sequencer, which most other chains haven't. Do you have a sense of why? Kind of, I have my own ideas, but I'm curious, like, your perspective. Why do you think Fuel chose to prioritize this type of feature when so many other rollups, across the space, they haven't, and in fact they're making lots of money by having it centralized.
yeah. Yeah, I think having worked with you guys for quite a long time now, and spoken to you directly and got to know you guys, I think you guys are very dogmatic in your in your view on Ethereum, and it's it's the most successful L1 to date in probably human history, actually, to be decentralized, have significant uptime. And I think you guys are so dogmatic in being able in wanting to scale this decentralized computer and align yourself with the ethos of this movement. So, I think that's the most important, from my perspective. Anyway, that's one of the most important reasons that you've embarked on this initiative. I don't know. Am I right?
That aligns with how I feel, and one thing I like about Fuel is I feel Fuel is building for really building for the future, not just building for kind of a step forward today. That's why Fuel is building, a new virtual machine that we think is going to last longer, than the EVM, even though the EVM is still the most widely adopted. And yeah, it fits in with my view of why we're building this decentralized infrastructure here. Some of it to me is also it's economic. That, as you kind of alluded to, when oh man, I know we don't want to get too political, but you can see when an entity is receiving, a lot of money, when there's a lot of value flowing to an entity, there it's a really hard thing to give up. If you're a company that's earning lots of money from the government for something, you're going to lobby the government to keep funding whatever that activity is. So, you know, in some sense, when an economic system is created, you want to instantiate the economic model in a way that it'll perpetuate the values, the direction that you want to see. So by starting with a decentralized validator set, instead of having Fuel Labs earning tons of money off sequencer revenue and saying like, yeah, like we could decentralize, we'll just take a couple, maybe next year, like we're not ready just yet. Instead, we have, this validator set that there's companies like Simply Staking and many other staking providers that are incentivized to want it to stay decentralized because they're the ones that are now part of this community. So I think
Yeah,
having
for
that
sure.
in such an early stage of the project was important to me.
I just want to add one more point,
Yeah, sure.
which I still find incredible. The Aztec study that I quoted, the
Sure.
analysis. If you apply a very conservative multiple, say 20 on those cash flows that the cumulative sequencers are producing, you get to like $3 billion like right now. And I would argue, roll ups are still in their growth stage. So consumption of services on a roll up will increase significantly, especially because for various reasons, the app chain thesis hasn't quite
Mhm.
caught on, and we see applications starting to take roll ups more seriously. That significant volume that's moving on to roll ups will translate into a higher flux going through the sequences. And so these cash flows, regardless of whatever multiple you apply to them, the value of the sequences will actually go up significantly going forward. And I'm incredibly bullish about this. Whether it's realized or not, in a certain time frame, I don't know. But if stakers and token holders can realize some of that value, I think it's going to be hugely beneficial for all of us.
Yeah, I agree. And as we said, it kind of fits into the ethos of what we're trying to make with crypto, something that is more democratized and open to everyone.
Yeah, for sure.
Um, Cool. Now I wanted to kind of like I think we did a really good overview here. I want to get under the hood a little bit and talk about how the sequencer actually works and how it fits in to the fuel stack. So, I think you kind of alluded to this a bit in the beginning, but could you maybe walk through like I'm a user on Fuel. I'm sending a transaction. I'm swapping on a DEX. I'm transferring a token. How does my transaction end up interacting with the shared sequencer? What's the life cycle of that transaction?
Yeah, that's a great question. Let me just start off with just outlining who are the main users of the sequencer, right? So the three main user groups
Yep.
that we are aiming to deliver, have some sort of interaction with. They are primarily the fuel token holder, the fuel V2 token holders, whether you've got a vesting allocation, or you've bought fuel V2 from the open market. There's the second user group, that's the roll-ups themselves, and I pluralize that on purpose because, of course, in the not so distant future, we'll be interacting with multiple roll-ups. And then the validators are the third user group, right? So let's start off with that first user group. So as a user, I want to be able to bridge my token. I want to be able to stake it and delegate to a validator. I want to be able to claim rewards. I want to be able to acquire those rewards and then maybe withdraw it from the sequencer back to Ethereum and do whatever I like with it. Maybe move it to Ignition. Those are the main user stories that we've satisfied on the Fuel sequencer. And then as a Fuel rollup for that second user group, we've architected the sequencer to be able to ingest blob data from Ignition. So and that's multiple rollups right now. There is a
Mhm.
bandwidth limit, and that's due to various reasons, the architecture and the schemes that we've opted for to build this initial version, as well as that just hardware and physics really. And then the third user group, and of course we'll go into more detail around that, but and the third user group are the validators themselves. So the validators play a pivotal role in powering this network, and they have a bunch of jobs to do. One of which is to sync with Ethereum and to be able to relay the state of Ethereum to the sequencer, so the sequencer knows who's bridged what assets and when. And the other thing is obviously to come to a consensus on blob data coming through, that's being posted onto the sequencer, and then finally, settling back to Ethereum, which is fundamental if we are trying to use the rollups to scale Ethereum. So those are the main three user groups that we've attempted to satisfy. So in terms of a transaction on the sequencer, really, the tokens that are bridged onto the sequencer are used to provide and provision economic security, and this basically protects the sequencer from being leveraged in a malicious way, whether it's double spending attacks or some kind of DDoS. The malicious actors are very creative, and so it's probably not like easy to list all of the ways they can attack it, but suffice to say that the staked assets are a way to provide economic security. And in addition to that, it keeps everyone aligned, because if you do behave maliciously, whether you're a validator or a user, you could be slashed, right? And that's a very important mechanism to enforce good behavior overall. So yeah, those are the main use cases for users and validators. And of course, as I mentioned, the rollups start to post blob data, and this blob data gets amalgamated with other transactional data occurring on the sequencer, and a block is produced, and then subsequently, after say 4,096 blocks, a summary of the state of that sequencer is put together in the form of a Merkle root, and that's transmitted by way of a function call onto Ethereum. So that's the entire cycle of what happens on the sequencer and some of the various features.
Gotcha. And once that Merkle root reaches Ethereum, that's when the rollup is kind of reaches, I don't know if you say finality, reaches the economic security of Ethereum itself, right?
I wouldn't say economic security, but that basically completes the entire scaling loop, if you will.
Yeah.
The economic security on the fuel sequencer has been architected such that the sequencer has its own validator set, and so it has its own economic security that's underpinned by all of the stakers of the fuel token, and that's separate from Ethereum. Sorry.
I guess what I was saying is that the sequencer itself has its own economic security, which ensures the consensus around sequencing. It ensures that the right validators are taking the right roles. Once this data reaches Ethereum, once it's in the Ethereum contract, that's when you get Ethereum security, like security of the Ethereum network, right? As opposed to security of the fuel sequencer network. Is that sound correct?
Yeah, that sounds about right. Yeah. So essentially, all of the activity that's been transmitted to Ethereum gets enshrined in blockchain history, essentially. Yeah.
Gotcha. That makes sense. Cool. So let's go a little bit deeper, and I want to understand how this system is architected. You said that there's a chain, this chain that has people staked and sequenced to it. How does that in practice? First of all, how is it constructed? I know you guys used the Cosmos SDK. So you tell me a bit about the Cosmos SDK, why that was chosen, what are the other components of the stack, and how do these pieces all kind of like fit together?
Yeah, of course. So really, we started working on this project, I think, last February. So it's been quite a roller coaster ride with you guys. So of course, the mandate was to get this decentralized sequencer MVP out of the door and production ready as soon as possible. We'd have liked to have more customized components and features, But the reality of the situation was, time was we were pressing for time. So we opted, as you already stated, the Cosmos SDK and Comet BFT. We feel, as simply staking, that this is probably the best blockchain off the shelf that you can get right now. It's fully open source. It's battle tested. Like, loads of projects use this all the time and probably don't give it reference to, it deserves a lot of praise for this. And we, as simply staking engineers, have a lot of experience with this stack. We were Genesis validators for the Cosmos Hub, and we've been engineering stuff with the Cosmos ecosystem and various app chains for a very long time. So we were very comfortable in devising this sequencer out of that stack. So those are some of the motivations for using that. So we've utilized Comet BFT, which is, for those that aren't aware, it's essentially a consensus engine and peer-to-peer networking library that you can use off the shelf. It's very, very powerful.
People might know this. This was previously known as Tendermint. Yes, people might be
previously known as Tendermint. Correct. Yeah.
People might be familiar with that name.
Yeah, for sure. That's a great point. And then we use the Cosmos SDK, which is essentially a library that provides you with a number of features associated with blockchains that we take for granted. So this could be like an accounts module to manage accounts, transfer assets back and forth, distributing assets, governance modules, and staking modules. The list goes on, but essentially you get a lot of this functionality out of the box for free, which expedited delivery of this bit of infrastructure significantly. So without it, we would have been stuffed, and we would probably not be on this podcast talking right now about a successful operating fuel sequencer. We would probably still be in the trenches building a lot of this stuff. So kudos to the Cosmos community. We love you.
Makes sense. I mean, yeah, the Cosmos stack, the Cosmos SDK, and Comet BFT is some of the most battle tested tech in crypto, I think, right? It's stood through ups and downs. I know, even the whole Terra collapse. One of the positives that come out is people are like, well, at least the Cosmos SDK held up pretty well. At least
yeah, for sure.
Held up well.
As a side note, the Terra chain utilize this feature that we actually utilize in the fuel sequencer, which is vote extensions, and this allows us to essentially get outside data, whether that's another network or some sort of time series from weather or pricing for the case of Terra, into the blockchain itself. So we've actually utilized a lot of that capability that previous projects have been the vanguard for.
Yeah, it's, I guess, the nice thing about Cosmos, you get to build on the shoulders of giants. But tell me a bit more about that, because my understanding is those vote extensions, that's related to how the sequencer chain connects to Ethereum. Is that correct?
Yeah, in a nutshell. So essentially, we've got this component called a sidecar. So actually, let me go back a bit more to tell you, there's actually a data flow.
What are all the components?
Yeah. That's a great question. So, but actually, before I get there, I just want to say, so we've got the Cosmos SDK and Comet that we're utilizing, but that's been customized in multiple ways. And in addition to that, we've built two modules, so the bridging module and the sequencing module. And as the name suggests, the bridging module takes care of getting the tokens from Ethereum onto the sequencer, and subsequently the sequencing module handles the blob data being ingested by the sequencer network. So the names convey what their properties are, but I thought I'd just stress that. So on Ethereum, there are some smart contracts. These are the interface contracts and the proxy contracts. And essentially what these contracts allow an ETH user to do is to invoke a series of a number of functions on the sequencer remotely. So it's like a remote control for the sequencer. And specifically, there are these two events called deposit and authorize with a Z. So we've got another component called a sidecar, And this is a piece of infrastructure that all validators have to run alongside a Geth full node. And essentially, the sidecar is continuously listening out for these deposit and authorize events. And if there is a specific event that occurs, it will then be grabbed by the validator and placed inside a block using a special transaction type we've developed called an injected transaction. Again, we can go into more detail. So essentially, that's how the outside information gets into the sequencer, how we can develop this bridge. And the bridging mechanism is a tried and tested method, which is simply very similar to IBC, really, where you've got the asset that's collateralized on the ETH side where it lies, it's locked, and then a subsequent new synthetic token is minted, and that is the token that you're interacting with on the sequencer. And in the event that you want to withdraw it, it's simply burnt on the sequencer and unlocked on the ETH side. So that gives you an overview of how the bridging technology works and what's actually powering it.
That's interesting. That makes this chain, it's not a rollup. The sequencer is not something that inherits Ethereum security, but it is something that is connected to Ethereum, right? So would it be thought of in some sense as more of like a side chain?
I think you could describe it in that way. I describe it as like an L 1.5. It's not really an
Okay.
L1 in its own right. It's kind of
It,
the problem we find ourselves in, and I'd be interested to hear what other people think about this, is you can post probably to Ethereum directly, but it's going to be incredibly hard when we have hundreds of rollups all interacting with Ethereum. We get to the same problem that we're trying to solve, which is congestion and high gas costs. So I would say it's an L 1.5, and it currently has its own economic security, but we haven't done significant research on this. But I don't see why we can't plug into other restaking platforms and inherit security from Ethereum or other well staked chains
yeah.
by that mechanism. So there's other ways to inherit security, but we've opted for its own validator set for this version of the fuel sequencer. We don't need to rule out different architectures going forward, though.
Gotcha. Yeah, it makes sense. I think the definitions get all a bit blurry here when we talk. Are things layer ones, layer twos, at layer 1.5? I think, and I've seen like in the Bitcoin, there's a lot of talk of Bitcoin layer twos, which seem to have Bitcoin community seems to have a very different definition of what a layer two is versus the Ethereum community. So,
Yeah,
yeah, it can be tough to kind of classify, especially something like the sequencer, which you're saying like it really like it's not an independent L1. It's not like a full, roll up L2 like fuel ignition is. It's kind of got a mix of different security properties and interoperability properties. Right?
yeah, for sure. Each to their own,
Yeah,
I say.
exactly. It's its own thing. It's just the fuel sequencer. So the components you're mentioning, there's the smart contracts on Ethereum layer one. There's this sidecar which lets, kind of information, be pulled from Ethereum onto the sequencer. That plugs into the Cosmos chain. And then I believe I'm not sure if we mentioned this. I believe there's another component, the ZK component, which connects the chain back to Ethereum layer one. Or I think not, maybe you can speak to that whole side. I think it's not ZK yet. What's the final component of the system here?
So everyone who just watched this, there was a massive alpha leak by Dave just now. Um, so the mechanism by way we settle to Ethereum is actually currently a multi-sig. We had in our launch plans a component that was powered and powered by ZK technology using a ZK VM. But when we were developing the sequencer in this tight timeline, we realized that actually the ZK VMs weren't really production ready. We were incurring a lot of problems. So instead of delaying the launch of the sequencer, we opted to fall back on a multi-sig as a short-term solution to be able to settle to Ethereum and facilitate withdrawals. Without this component, the decentralized the fuel sequencer becomes redundant. So we need to be able to connect to Ethereum in some way. So there is a contract called the Fuel Stream X contract on Ethereum right now, and what that contract essentially allows us to do is to treat ETH as the light client for the sequencer. So every periodically, roughly around 6 or 7 hours, or in block time 4,096 blocks, a Merkle route is transmitted to ETH. And the leaves of this Merkle route are all of the individual sequencer transactions. Now, this is, as I mentioned, a multi-sig. So there are various entities on that multi-sig, all verifying each other. So there's a reduced chance of malicious behavior between the entities on the multi-sig. Of course, the multi-sig is only as strong as how you keep your secret credentials, right? That unlock the multi-sig. So it's not like a fully 100% solution. But as I mentioned, it's a short-term solution until we move over to the ZK solution. So with the ZK solution, in addition to transmitting this bridge commitment, we will be generating a proof. I think it's around 800 bytes at the moment, and we're using SP1, Succinct's SP1, and the test currently shows it costs about $1 and 20 to 30 minutes to generate. So that's currently in development and is on testnet right now. We're just doing some battle testing and load testing, and then there'll be an audit hopefully very soon, and then we'll position that component for mainnet deployment hopefully in the next 2 months or so. So yeah, that's how the settlement works, and that's where the ZK element will eventually come in.
Interesting. Yeah, I mean that fits into kind of one thing I like about, I think, Fuel's philosophy, which we've called ZK pragmatism, which is the idea that ZK is amazing. We love ZK. People would often ask Fuel, why are you an optimistic rollup? Why are you not a ZK rollup? ZK rollups, were seen as. I think this question is asked a little bit less often these days, but for a long time, everyone was seeing, ZK rollups are going to be everything, and we've seen that ZK rollups are still, the dominant rollups are still all optimistic rollups these days, and that ZK tech's amazing, but it's still not quite there yet for all purposes. So for something like this, it's like actually it's very nice to use ZK to do this like light client bridge between the chain and Ethereum once the tech is ready. And it sounds like it's just about there, but it was not quite there in time for the chain to launch. So
yeah, for sure. I couldn't agree more with what you said. I think back in the last 6 months or so, the narrative had somewhat superseded the actual reality of the technology. But I think a lot of great work has been done by the ZK community and the privacy community more generally. And I think for this basic use case, which is just proving a summary of the state of the sequencer, it fits pretty nicely and is probably production ready. So we're really excited to be in a position to deploy this in the short term, and I think everyone will benefit from this. The entire Web3 community will benefit from this experience.
Nice. Cool. Well, earlier you had mentioned, you talked about kind of some of the different user groups that users can stake. There's validators running nodes, things like that. For everybody listening here, I was hoping you could kind of share a bit of how can people get involved? How can people stake on the sequencer if they'd like to stake? How could entities run validators if they're interested in that? Like, what are the different ways that people can get involved with the sequencer?
Yeah, so in terms of getting involved, so if you are a prospective validator, the hardware requirements are pretty low actually for this application. We're talking about 4 cores, 8 gig of RAM, and 200 gigabytes. There are several phones that are more powerful than these hardware requirements. So the spec is quite low. What is the costliest bit of this deployment is the bandwidth cost. So at full whack, when we were load testing the sequencer, we were probably consuming around about 10 terabytes worth of bandwidth per month. Now, I got a quote from AWS, and this works out to be about $12,000 annually. So it's still, relatively profitable to be a validator. But at peak times, which we'll probably see, in the next, I don't know, 6 to 12 months, when we ingest more blob data, the bandwidth costs will jump up. So that covers the validator requirements, and I should also say that the Fuel docs have a very good walkthrough of how to deploy a validator. We encourage not just professional validators, but all kinds of validators to come on, and we intend to increase the active set significantly over the longer term horizon. And what I would say about stakers is, I think as I mentioned, there's a significant potential upside. As we've seen from the centralized sequencing infrastructure, there is a cash flow to be leveraged, and it's just a case of seeing how the space evolves. And I think stakers will be in a position to accrue value as a result of these cash flows in some way. It's hard to tell at the stage, because obviously we're still making it up as we go along and seeing how the industry evolves. But I think there's a significant opportunity out there for people to get acquainted with how to stake and how to participate in economic security.
Mm-hmm. Makes sense.
And I should also say, actually, yields are north of around about 50% right now. So it's quite a juicy yield for any staker.
Yeah, that is a good level of yield. So
Yeah, for sure.
cool. I think we had a video to show on how people can get involved and stake if they'd like to.
Yeah, let's play it. So I've got to confess, this video shows us Fuel V2 tokens already bridged onto the sequencer. And what I've done here is I've selected simply staking as the validator using the Fuel interface. As you can see, the URL is placed there. I'm sure we'll tweet out the URL, but it's very easy to use. You can choose which validator you want. You simply specify how much fuel you want to stake and who the entity is, and you just click the button and sign the transaction on Ethereum. What's happening now is the transaction is being propagated, and that event data I spoke about earlier is being propagated to the sidecar, and the sidecar will wait for Ethereum blocks to finalize, so that the potential of a reorg is quite low. And once that block is finalized, a proposer on the sequencer will pick that event up and put it in a block, and then all of the validators will attest to that block being constructed appropriately, and your delegation will be reflected on the blockchain. So you can see here in the video, I highlighted a view in Explorer, and that's the actual Ethereum transaction that you're presented with on Etherscan. And then, yeah, all of the sequencer information that I conveyed is happening on a different block Explorer, which we'll definitely tweet after this.
Cool. Makes sense. Thank you for sharing that. Awesome. We're getting towards the end of our time here, so I think we can open up for any question and answers. If anybody has any questions about the sequencer, about staking, anything around there, I think. Okay, looks like we have no questions so far. Yeah, anyone feel free to post in the chat or comments if you have questions. Cool. If not, let's see. I don't know if there's anything else we want to close up on. Is there any other kind of yeah, we'll go ahead and we'll answer any questions that we have on Twitter, on X, and on YouTube. Yeah, Chris, do you have any, or Garuda, do you have any closing thoughts on the sequencer, on any of the other things we've discussed today?
Yeah, I think what we've delivered so far is an incredible achievement, but we're not resting on our laurels. We're working with the team are working hard on developing the next iteration of the sequencer. I would say that being able to ingest large volumes of blob data is really a fundamental component of the next iteration of the sequencer, and that's what we're heads down focused on working on. So we're coming up with ideas and prototyping ideas. It's going to take some time until we have a production ready solution, but we're totally focused on this next version.
Cool. Very exciting. Awesome. Well, Garuda, thank you so much again for joining to talk about the current state of Fuel's decentralized sequencer and all the exciting developments we have going forward. And thank you everybody for joining in. Yeah, again, if you have any questions, feel free to respond on Twitter or on YouTube, and we'll try to get back to you. And yeah, see you guys next time.
Thanks, David. Thanks, Fuel community. Really appreciate the time.